Today we're going to look at the notes for both Learning Target 1.2, solving two-step linear equations, and Learning Target 1.3, justifying each step in solving the equation. Now, a quick heads up on justification, and I mentioned this in class. When you are justifying something, you are saying why it happened or what your reasoning is. And I think I mentioned in at least one class, if you came home after your curfew, your justification to your parents about why you came home after curfew would not be, I came home after my curfew. You might say, hey, my friend's mom was going to drop me off and her car ran out of gas, but there's some reason that I'm late. So think of that when you're talking justification. It's not just what you did, but why you did it and what allowed you to do it. So when we're solving equations, we're going to use those properties of equality that we saw in Learning Target 1.1, the addition, subtraction, multiplication, and division properties of equality. I would encourage you, though it is not required, to make sure that you are keeping your equal signs lined up, and that is required. You might, and hang on just a second, I need to change this. It might be beneficial to you to actually draw a dashed line down through your equal sign to make sure they stay lined up from top to bottom. Now I did that dashed line in green because it's not a requirement, but it is a recommendation. When I look at this equation, 10x plus 3 equals 33, on your note sheet it says first look at each side of the equation as if it was its own simplification problem, the kind of problem that you did in the first learning target. So first, I'm going to ignore the right side of the equation, the 33, and I'm just going to look at the 10x plus 3. I don't see any distributive property to do because there aren't any parentheses, and I can't combine like terms because the x and the constant aren't like terms. Then I would ignore that side of the equation for just a moment and look at the right side and see if I can just simplify that, and 33 is already just simplified enough because it's a single number. So in this section, Learning Target 1.2 and 1.3, you will not have any that you can simplify first, but you will see some of those in Learning Target 1.4. When I want to solve the equation, the second part of the process says use addition or subtraction to move variable terms to one side and constant terms to the other side. Well, on the left side of the equation at this moment, I have both a variable term, 10x, and a constant term. I don't want those on the same side of the equation. When I look at the other side of the equation, there's a constant there. So it makes sense to me to move this constant to be with the other constant. Now I can't just move my positive 3. I have to think about how I can eliminate it from the left side of the equation. Since it's a plus 3, I would subtract 3. And the subtraction property of equality says I can do that as long as I do the same thing to the other side of the equation, so my equation is still in balance. So I'm going to do a quick vertical check, which is did I do what I intended to do? I wanted to get rid of the constant here. A plus 3 and a minus 3 would add together to be 0, so I did eliminate the constant. The horizontal check is, here's my equal sign. Did I just do the same thing to both sides of the equation so my equation is still in balance? And I did. I'm subtracting 3 from both sides. So I end up with 10x equals positive 30. Now, I have a single variable term on one side and a single constant term on the other side, so I go to the third part of the process, which is to try to isolate the variable. I don't want 10x, I want to know what 1x equals. Since the 10 is connected to the x with multiplication, I would divide by 10 to isolate the variable, but the division property of equality says what I do to one side of the equation, I need to do to the other side of the equation, so it's still in balance. So the positive 10 would cancel with the positive 10 here. That's just a 1x equals 30 divided by 10 is 3. Now I'm going to show the check on a couple of these, but not all of these. To check this equation in your calculator, you would take 10 times 3, because this says 10 times x, and we just solved to get x is 3, plus 3, and hit the equals on your calculator, and you'd get an answer of 33. That matches the other side. So this equation has been solved correctly. Now the justification is what did I do, and I kind of talked through that as I did it, and why did I do it, and what allowed me to do it, what property. Because it takes a while to actually write that out, I typed it up and put it down here in the notes. So what I did, I subtracted 3 from both sides of the equation. Why? To eliminate the constant on the left. What allowed me to do that? The subtraction property of equality. And again, what I did next, I divided both sides by 10 to isolate the variable. So what I did, I divided both sides by 10. Why? To isolate the variable. And what property allowed me to do that? The division property of equality. Now in this case, the constant is on the left. But if I look, and I'm going to do this little dash line, very light, hardly noticeable, just to keep my equal signs lined up, I still have on one side of my equation a variable and a constant. I don't want them together, since again there's a constant on the left. I'm going to move this constant to the left side of the equation to be with it. Since it's a subtraction in front of the 50, or think of it as a minus 50, to undo that I would have to add 50 to eliminate it on the right side. So I'm going to add 50 to the left side as well to keep my equation in balance. Negative 47 plus positive 50 is 3. And then what's left on the right side here is a 3x. And I double check. Yep, a minus 50 and plus 50 would combine together to be 0. So that did eliminate the constant there. Now, 3 times x equals 3. So I have a single variable term on one side and a single constant on the other side. I want the value of 1x, though, instead of 3x. Since there's multiplication between these two, I would divide by that 3 to isolate the x. So I have to divide by 3 on the other side as well. This 3 divided by 3 is 1. 3x divided by 3, because these 3's would cancel, is x. For your final answer, reverse this. I want your variable on the left side, because if you were ever going to use this value of x later, your brain wraps around x equals 1 much more easily than it does 1 equals x. Now I talked through what I did, but here's the actual written justification for what I just did. I added 50 to both sides, so what I did, y, to eliminate the constant on the right. What allowed me to do that? The addition property of equality. Then I divided both sides by 3 to isolate the variable, and what allowed me to do that? The division property of equality. So all of this justification on the right is learning target 1.3. Now for this one, and again I'm going to keep my equal signs lined up. I did show you in class sort of what can go wrong if you don't keep your equal signs lined up. There's a variable term on the left and a constant and variable term on the right. Since I want the variable on the left, and there's already one there, I want to undo this minus 7n to eliminate that on the right side. Since it's a minus 7n, I would add 7n to eliminate it. And what I do to one side, I also do to the other side. That's going to give me 12n equals positive 3. Now, at this point, a single variable term equals a single constant. This is 12 times n, so to undo that multiplication, I would divide both sides by 12. Plugging this in your calculator, you would put 3 divided by 12, and it works out to be exactly 0.25. So in this case, it's perfectly fine with me if you give your answer as a decimal. If your answer was, say, y equals 4 divided by 12, if you put 4 divided by 12 in your calculator, you put 4 divided by 12, and you'd get 0.3 repeating, and it would fill up your calculator screen. As soon as you see that decimal fill your calculator screen, you are no longer allowed to give me a decimal answer, because you would either have to round the decimal, and now it's not an exact answer, or you would have to put the repeating bar over the decimal, and then you would not be able to reuse that number later if you were going to use it in another calculation. So if something like this happens, put it in as a division if you want to, and then look on your calculator for how to convert a fraction to a decimal, and I did just demonstrate that in class. So this, the answer would have to be simplified to y equals 1/3, and you would have to give it as a fraction. Or, if it turned out to be a mixed number, give it as a reduced mixed number. So, exact, reusable answers are what are required in this class. I'm going to show a little bit of the check on this one because it's slightly different. I would have to do 5 times 0.25 in my calculator equals, and 5 times 0.25 is 1.25. But then I'd have to go into my calculator and put 3 minus 7 times 0.25 for the other side. Well, your calculator is going to say 7 times 0.25 is 1.75. and 3 minus 1.75 is 1.25. Both sides of the equation are equal when I put 0.25 in for the variable and simplify, so n equals 0.25 is the answer. Now, just looking at the justification here for this one, what I did, why I did it, and what property allowed me to do it. I added 7n to both sides of the equation to eliminate the variable on the right because of the addition property of equality. And then I divided both sides by 12 to isolate the variable because of the division property of equality. Now the last one students sometimes look at and they think this is so totally different from any of the other problems and they don't even know where to start. But honestly, it's pretty much the same as all of the other problems we've done. We have a variable term and a constant on the same side of the equation. I don't want both of those on the same side. On the right side, there's a constant. So just like we have done in 2 of the 3 problems so far, we want to move the constant to the other side of the equation. Since it's a plus 3, I would eliminate that by subtracting 3 from that side, and what I do to one side, I would do to the other side to maintain that balance because of the subtraction property of equality. The plus 3 and minus 3 combine to be 0, so what I'm left with is m over negative 5 equals negative 5.5. Here's where it's different than the other 3. This is not negative 5 times m. The fraction bar is division. But the way I undo division is with multiplication. So I want to get the m by itself. It's being divided by negative 5. To undo that, I'm going to multiply both sides by negative 5. And in this case, because I'm multiplying by negative 5 and I'm already using a dot on this side as the decimal, I'm going to put the negative 5 in parentheses. So, negative 5.5 times negative 5 is positive 27.5, and this side is just m. So m equals 27.5. Now for y, that side is just m. When you multiply the left by negative 5, it's like multiplying by negative 5 over 1, because I can turn anything into a fraction, any number into a fraction, by putting it over 1. When I multiply fractions, so I'm multiplying my negative 5 times my m over negative 5, I multiply straight across, which means this really becomes negative 5m over 1 times negative 5 is negative 5. My negative 5's cancel, which is why this is just m, because the multiplication undoes the division. Now the explanation, the justification, is very similar, except for this is the one we don't use the division property of equality at the end. So what I did, why I did it, and what property allowed me to do it. I subtracted 3 from both sides of the equation to eliminate the constant on the left. The subtraction property of equality let me do that. I multiplied both sides by negative 5 to isolate the variable. The multiplication property of equality allowed me to do that. Now, for tonight, look at your assignment. You have a worksheet to do with 5 problems. Do those, check your answers online, and come back to me with any questions you may have. Thank you.